how to design relational models. UML, the design language. UML stands for Unified Modeling Language, and this is a standard vocabulary and components for modeling, designing, and visualizing information technology systems. It's a language, but it's a visual language of design. There are various kinds of diagrams and components for designing all sorts of processes and parts of information systems. So here I have an example of actually use case diagram, which describes how a particular user or different types of individuals and different types of users interact with the system. We may or may not be working with this kind of diagram in this course, but there are many other kinds: deployment diagrams, activity diagrams, state chart diagrams, and class diagrams, which is the one that we're going to be mostly working with. So there are a lot of components for databases and for database modeling that we need to understand before we create a structure to create our own database and manipulate and understand databases. So the first is the entity, as we kind of mentioned, which get translated to a table, also called a class, and I'll use these terms almost interchangeably. Each table is going to have the attributes, which are also called fields, also called columns, also called features, blah, 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 so many names. Each attribute has its own data type. So it's binary. Usually it's going to be one of these actually. Either binary, that is true or false, 0 or 1, integer, which is non-decimal numbers, 1, 2, 3, 4, 5, 6, 7, a decimal, 1.34, and so on, 3.14, a date, and character, which is also called text or string. And this is usually really the 5 ones, but they can kind of get broken down depending on the system, float versus decimal, and it does get a little bit more complicated, but essentially these are the basic ones. Each attribute has other properties. So the attribute has its own data type and also potentially other properties. Everything has like additional properties, which are part of the metadata of the data itself. So things like name, length, description, restricted values, and so on. And we'll kind of talk a little bit about this. One of the important parts of the table is the determination of the primary key and the foreign key. So the primary key is one of the attributes of the table that you select to be the thing that uniquely identifies a record. So something like a name is usually not a good primary key because a name can be repeated. People have the same names. State agencies have the same name. You know, there's the Environmental Protection Agency in Oklahoma, and there's an Environmental Protection Agency in Utah. So if you're keeping a federal database of all the agencies, you can't just use the agency name to uniquely identify. So you need a kind of a new agency ID that is strictly and forcedly unique. The foreign key is the attribute that links two tables. Although we were kind of thinking of tables linked, you know, when we draw them, we link them with a line. We link them with a line here. But when we actually implement, what we have to do is take the primary key of one table and put it in another table and repeat it. And that's actually how the linking works. And we're going to show that how we're going to apply that so you can actually see how that works. Relationships. Relationships are connections between tables. There are three main kinds of relationships. We went over this: one-to-one, one-to-many, or many-to-many. In RDBMS, relationships are created by using primary keys and foreign keys. Once again, when we model, when we design, we just create a line. But when we actually implement, what we're essentially doing is connecting two attributes of two tables to link them together. So we have the example here again of the states of the state's data and the agency's data we're keeping. And notice that we drew the line here. We identified that this is a one-to-many, that is, agencies have to have one at most We're only using maximum here. If we had more information, we would have the minimum, but let's just focus on the maximum. Agencies can have at the most one state, and state can have at the most many agencies. So it's not restricted to just one. But this is a kind of, this line is imaginary. This is not implemented. This is just for visualizing. What actually creates the connection is this right here. So you determine the primary key here in the state. You determine the agency ID in the agency table. And then to actually connect them, we need to make sure that we have the state code here in the agency table as the foreign key. Now I write this out first before I even create the table, just so we know, because we take this as the blueprint that we then apply. So that's the order of things. And then I will show how you actually create it in the database. But this is how you actually establish the connection, by creating an attribute here that we're going to call the foreign key, and that we're going to link with the primary key of the related table. And of course, you may ask, wait, why did you take the primary key of the state information, the state table, and put it in the agencies? And why don't you take the agency ID and put it in the state? And actually, if you think about it, if you play around with this, you're going to see that it doesn't work. It just structurally, it doesn't work because of the table format of the relational database model. And the rule is, it's actually a fairly straightforward rule that you should remember, is we're always going to take the primary key from the one side. So this is the one side, the one's here, the state is one, and put it in the many side. Oops. So take PK from, this is my terminology that I like, that I think is very straightforward though. And you can find this explained in different ways. Take the primary key from the one side and place it in the many side. Now, if you say, well, what if you have a one-to-one relationship? Well, if you have one-to-one, it doesn't matter, actually. It might not matter. Now, it depends. It can get a little bit complicated. And you may say, well, what if you have many-to-many relationship? Well, if you have many-to-many relationship, we need to break up the relationship and create an associative entity. And we'll talk about that as well. The relational databases cannot implement many-to-many. Many-to-many would be if this was each agency can belong to many states, and each state can have many agencies, then we would have many-to-many, but we cannot implement that directly. So we have to create an associative table that breaks it up. So that's how we create the foreign relationship, and this is how we read the cardinality. Student database example with full cardinality. Okay, so just so you're understanding of the minimum and the maximum, because I brought this up and this is important for understanding these databases. This is the other kind of notation, the more UML class notation of minimum and maximum cardinality. And I'm just going to read it here to you. So first, let's identify the entity. We have a student entity, student, and these are the attributes: student ID, first name, last name, address, phone number, emergency contact. We have a student course, student ID, course ID, final grade, and we have courses, course ID, course name, professor name, location, meeting time. And actually, this was broken up because, do I have that here? No, I guess I don't have it, but we'll kind of come to it later on. So the way to read this is the following. Each student has at minimum 0 course. And also this call, I like the name for this entity here as enrollment. Enrollment. So it's called student course, but we can call this enrollment. So each student doesn't have to have enrollment, any enrollment. We can be a student, we can put them in the database, but they don't have to have any enrollment. But if the student does have enrollment, they can have one or more enrollment, one or many. Now, each enrollment, and this is kind of sometimes difficult to think because enrollment is an abstract concept. Enrollment is not something you can touch. It's not tangible, it's abstract. But think a bit about it so we kind of try to understand it. Each enrollment itself only refers to minimum one student and at maximum one student. And that is because each enrollment is really the connection between a particular student with a particular course. The same student enrolled in another course is a different enrollment. So it's not the same enrollment. It's the same student, but it's not the same enrollment. And that's how this makes sense. And here we have the same thing. Each course does not have to have any enrollment. Maybe, of course, nobody signed up for it, so it has no enrollments. But each course can be enrolled multiple times. Sometimes there is a limit, right? Each course may be enrolled by, at any one time, it can be enrolled by 10 or 20 or 30 people, but usually more than one, so we say many. Now, the other way around, each enrollment has to have a course. The minimum, this is why the minimum is important here. Each enrollment has to have a course, otherwise you don't have an enrollment, because the enrollment is the course with a student. And once again, each enrollment only refers to one course. Same thing, once again. Why? Well, each enrollment is this one particular student with one course. So a separate student in the same course is a separate enrollment. And this is how we understand the full cardinality. And of course, let's remember that this is the schema view, and the schema view gets translated to a table view. So if we're looking here, what do we have here? Course ID, course name, professor. So this is the course table. I just wanted to add it here so we can actually see the data records. You can see the records on the data view. So first we need the structure, and then we have the records. And then we also have the enrollment data view here. And you can see we have a list of courses, all individual courses, and then the enrollment, we can have the enrollment is just some randomly generated number, the enrollment ID. Now we have the student ID. Student 101357 is enrolled on course 6080 for the fall. Student 102885 is enrolled in INF 60. And also the same student again is also enrolled in course 6080 in the same semester. And we can see here that each student, I don't have the full cardinality here, but if we go back, each student can have many enrollments, but each enrollment is only one student. So this is one enrollment over here. One enrollment has this student here, 885. Now, this enrollment only has one student right here. This other enrollment has the same student, but it's another enrollment. So the student has multiple enrollments. The student here has enrollment 2 and has enrollment 3. But the enrollment itself only has one student. So this might take a little while to think about and understand. Also note that the semester is related to the enrollment and not to the course. So we have to kind of add this year that wasn't here. And I think, the final grade this year, I added a grade. The grade is not associated with the student. It's not an attribute of the student. The grade is an attribute of the enrollment, of the connection between the student and the course. And a semester could be an attribute for the course as well. Like, this course is offered this semester and so on, but you got to be careful. Here, a semester is related to an enrollment, and maybe the course itself doesn't really need to have semester information because that has to do with when particular individuals enroll, but this could be different. So I'm going to cut it off for now, and we're going to come back to more of this soon.